Good morning. It's July 24th and this is your daily brief in science. Here's everything you need to know. Google DeepMind has introduced Aeneas, an innovative AI tool that aims to restore and contextualize fragmented ancient Latin inscriptions, marking a significant advancement in the field of epigraphy. This tool leverages neural networks to analyze extensive data sets, allowing it to detect patterns and recover historical information from damaged texts that have long posed challenges for researchers. Aeneas can estimate the chronological date of inscriptions within a margin of 13 years and identify their Roman provincial origin with 72% accuracy. This capability enhances the historical interpretation of these artifacts, providing deeper insights into ancient societies. However, while Aeneas increases efficiency, it still necessitates human oversight to validate its suggestions, ensuring the accuracy of historical research. In practical tests, Aeneas has demonstrated superior performance compared to traditional methods, successfully dating inscriptions within 13 years of the correct answer and improving the accuracy of experts when used collaboratively. Each inscription is given a historical fingerprint that details its content, language, origin, and parallels, facilitating more profound analysis. Prominent scholars, including Mary Beard, have praised Aeneas as a potentially transformative tool, capable of democratizing access to ancient history and reshaping research practices. Developed in collaboration with epigraphy experts from institutions like the University of Warwick, Aeneas incorporates contextual information, such as historical periods and geographic locations, to enhance the accuracy of its restorations. The project also includes educational initiatives aimed at promoting AI literacy in historical studies, aligning with frameworks from the European Commission and UNESCO. With a database containing nearly 200,000 inscriptions and images of 5%, Aeneas is well equipped to analyze and provide insights into various Roman texts, including decrees and epitaphs. A new study published in Nature reveals an intriguing connection between our gut and brain that could reshape our understanding of appetite regulation. Researchers have discovered that specialized gut cells can detect microbial proteins such as flagellin and send rapid signals to the brain, establishing a neural circuit from the colon to the brain. This gut-brain communication occurs within seconds, significantly faster than traditional immune responses. Notably, even germ-free mice, which lack gut microbes, still respond to flagellin, indicating that this response is independent of other microbial inputs. The study highlights that nearly half of the vagal neurons with PYY receptors are activated by flagellin, suggesting a distinct neural pathway for microbial detection that operates separately from nutrient responses. Additionally, levels of flagellin in the colon increase after eating, which may signal satiety through the release of PYY, a hormone associated with feelings of fullness. Disruption of this pathway, particularly in mice lacking the TLR5 receptor in PYY cells, leads to increased food intake and weight gain, underscoring its significance in regulating eating behavior. Researchers propose this mechanism could represent a new seventh sense related to gut microbes, complementing the 5 traditional senses. Further research is planned to explore how dietary changes affect the gut microbiome and behavior, potentially informing treatments for obesity and psychiatric disorders. Scientists are also interested in whether neuropods can detect immune-related signals, which could enhance our understanding of the neurobiotic sense and its health implications. While the study was conducted in mice, researchers emphasized the need for future studies to determine if similar mechanisms exist in humans. This discovery could lead to novel treatments for appetite disorders by targeting the gut's bacterial sensing system rather than focusing solely on brain chemistry. Overall, the findings highlight the critical role of gut bacteria in regulating appetite and energy balance, which may help explain weight regulation issues linked to variations in gut microbiota. Scientists have made a remarkable breakthrough by using lasers to heat solid gold to temperatures exceeding 14 times its melting point, while maintaining its crystalline structure. This experiment, published in the journal Nature, challenges the long-standing belief that gold would undergo an entropy catastrophe and explode beyond 1,948 degrees Fahrenheit, or 1,064 degrees Celsius. The findings suggest that there may be no upper limit to superheating if materials are heated rapidly enough, raising critical questions about the stability limits of superheated solids. The implications of this research extend across multiple fields, including spaceflight, astrophysics, and nuclear chemistry. By enhancing our understanding of hot, dense matter in extreme environments such as stars and fusion reactors, this study opens new avenues for technological advancements. The innovative temperature measurement method utilized ultra-bright X-rays, which could accelerate progress in nuclear fusion research by accurately determining the melting points of materials in extreme conditions. The research team, led by scientists from SLAC and the University of Nevada, Reno, along with contributions from various prestigious institutions, is continuing their work by measuring temperatures in hot compressed iron. This will help to better understand planetary interiors and high-energy density environments. The study underscores the importance of precise temperature measurements in extreme states, a challenge that has historically hindered progress in high-energy physics and material science. Additionally, the X-ray method developed could simulate the effects of extreme heat and pressure on materials relevant to planetary science. One of the researchers expressed surprise at the results, highlighting the unexpected nature of surpassing previous temperature limits for superheating. This research reflects over a decade of work in high-energy density physics and has significant implications for both planetary physics and fusion energy. Meta has unveiled an innovative gesture-controlled wristband that allows users to interact with computers through hand movements. This device utilizes surface electromyography, or SEMG technology, to detect electrical signals generated by muscle activity, interpreting user gestures even before they are executed. The wristband offers a calibration-free experience, enabling seamless interaction with computers. It accurately decodes muscle signals into computer commands, presenting a non-invasive alternative to traditional interfaces like keyboards and touchscreens. Development of this technology involved gathering extensive training data from thousands of participants, leading to a high-bandwidth neuromotor interface that performs effectively across different users. Recent prototypes of the wristband can quickly adapt to new users without requiring extensive training, thanks to sophisticated neural network algorithms. While advancements in non-invasive interfaces are notable, challenges persist in ensuring consistent performance across various users and settings. Unlike EEG-based systems, Meta's SEMG wristband operates at higher frequencies, facilitating immediate use without surgical intervention. It can recognize complex gestures, including handwriting, and connects via Bluetooth to execute tasks like cursor movement and message typing by tracing letters in the air, achieving a current handwriting speed of approximately 20.9 words per minute. Users can perform a range of actions, such as moving cursors and launching applications, simply by tracing gestures in the air, all without the need for individual calibration. Machine learning and AI play a crucial role in enhancing the wristband's ability to decode gestures and understand user intent, making interactions more intuitive. Designed for comfort and ease of use, this wristband addresses usability concerns of earlier EMG systems, broadening its potential applications. In a collaborative effort, Meta is partnering with Carnegie Mellon University to test the wristband on individuals with spinal cord injuries, with the goal of assisting them in operating computers despite limited motor function.
2025 is shaping up to be the worst year for measles in the U.S. since 1991, with over 1,300 cases reported across 40 states by mid-July. This alarming trend includes a record-breaking outbreak in West Texas, primarily linked to an under-vaccinated Mennonite community, which has resulted in over 700 cases. This cluster marks the largest since measles was declared eliminated in 2000. The surge in measles cases is compounded by declining vaccination rates, which have fallen below the herd immunity threshold of 95%. In some counties, such as Gaines County, vaccination rates have plummeted to just 82%. Notably, vaccination exemptions in Gaines County have risen dramatically from 2% in 2014 to nearly 20% in 2024, contributing to the outbreak's spread. Health experts emphasize the need for at least 95% vaccination coverage to ensure community immunity, as measles is highly contagious and can infect 12 to 18 others from a single case. Local vaccination clinics are stepping up efforts to promote the MMR vaccine, which is 97% effective when both doses are administered. Tracking measles cases has proven challenging due to reliance on voluntary reporting, which may lead to undercounting. Officials are stressing the importance of improved case reporting and community engagement to better manage the outbreak. Lessons learned from previous outbreaks, such as the 2014 case in Ohio, highlight the need for effective communication and community-specific outreach. So far this year, there have been 3 confirmed measles-related deaths, all involving unvaccinated individuals, including 2 children in Texas and 1 adult in New Mexico. The outbreak's spread has been further exacerbated by mobility and connections to communities in neighboring states and Mexico. Public health officials are drawing on past experiences to enhance response strategies, while some areas like Sedgwick County, Kansas, currently report no active cases. However, the overall situation remains concerning due to ongoing transmission and a decline in global vaccination efforts, which could threaten domestic health security.
This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.